Okay, this evening we're going to talk about capacitors. I have here a 30 microfarad capacitor at 440 volts AC. Um, as a reminder, and you probably can pause this and look at your handout on the capacitors. But the replacement capacitor, if I was replacing this one, I would have to do it with a 30 microfarad capacitor because we're supposed to have exactly the same capacitors. And since in our trade we only have two voltages, 370 and 440, and since this one's a 440, I have to replace it with another 440. So the microfarads have to be spot on and the voltage has to be equal or greater. And I talked before about I don't stock any 370s since voltages has to be equal or greater. There's no sense my stocking a 370. Now, capacitors, I got several of them here. We're going to do some things with them. How are they made? They're made like you can imagine, say, a strip of, say, aluminum foil that would be maybe an inch and a half wide and maybe 20 yards long. And we had two of them, and we put a piece of insulating paper between the two of them and then rolled them up. And one terminal would be hooked up one of those pieces of aluminum, and the other one be hooked up to the other one. And what that effectively does is it slows down the exchange of electrons between the two pieces of aluminum, and that's how they're made. And these are very, very helpful in our trade because capacitors give this motor more torque because, as we learned earlier, they're connected from start to run. And the motor manufacturer decides how many microfarads they want on that particular motor, be it a compressor or be it a fan motor. And what it does, one way I talk about it is if your bicycle, and I'm sure most of you have ridden a bicycle, if the pedals were lined up together rather than opposing each other, and you tried to pump, you've got the same power in your feet, but you're going in the same direction. It's sort of confusing, but it has an idea like that it delays the power somewhat on the start winding and it gives power to it. When we have a PSC motor, as we've talked about, that's the most common one. The run capacitors in there all the time. Motors like that, they don't need a whole lot of help getting going, but the faster they turn, the more air they move. The more air they move, the more current it takes, and then that run capacitor helps keep them going. If on a compressor we need to have some start, sometimes we just might momentarily jump run to start, and then within a second or two take it out. That helps get it going, and sometimes we have start components, be it a capacitor or PTC device to help get it going, and then the run capacitor keeps it going. There's several ways these things can be good. Only one way, that it works as a capacitor, in that it's not open and it's not shorted, and it's giving the reading and what it's supposed to do to help that motor. So if it's shorted out, it's like it's not there. It's just like jumping a wire from run to start, and we learned on that handout that you can't leave that in there like that or it's going to overheat. If it's open, nothing happens. You have no capacitance, and it's just might as well not even be in the circuit. They do have one other way they go bad. It's not very common, but it does happen. Sometimes something happens internally, and one job I went on, it had a 10 microfarad capacitor on it, and initially I checked with a meter, and it indicated that it was good, but that check just tells me it's working as a capacitor, but in reality that one was defective. Then instead of 10 microfarads, it was 3 microfarads, and the motor still overheated and went off. And I'm sure most of the time, most people say, well, we got a bad motor, and they change the motor, and you always put a new capacitor on it when you do that. That's just a matter of standard operating procedure. and that's a very rare occasion. I'm really happy when I find a bad capacitor because it doesn't take much to change them. It's sort of a pain in the neck to do it. So that's what it does. Now, we also in that handout learned how to hook them up and what it does. And so I've got a handy little dandy meter here, which I'll show in a minute. But if we take two capacitors and hook them in parallel, which I'm going to do, I'll hook this rascal up to here and this rascal up to here. And what I have is, just in case, I'm not sure you believe me, but I have a 30 and a 10 microfarad, okay? And when you hooked up in parallel, which I'm going to do, we get the sum of the two. In other words, I should end up with 40 microfarads. Now, if you're like me, you might be a cynic. And so I'm going to sit there and hook my handy little microfarad meter in here because that's really the only way to make sure that it's good. You know, just using there are other meters to do it, but I like them when they're separate for this because they have a battery in them, sometimes a universal meter. But I'm going to push this button and all right, we're getting there at about 42. I don't know if you can, I'm sorry, get this right in there. We can see 42 right there. It's not very clear, but it's 41.9. So that's within tolerance of two capacitors. Sometimes this knowledge is helpful. Years ago, I had a friend of mine had an old unit, and I had a couple of old 20s, and he needed a 40. And of course, bad things happen on a weekend. And I said, well, I'll put parallel in there, and I want to come back in next week or whatever and replace it. And we never got together. And about 13 years later, he bought a whole new system, and those two old capacitors were still in there doing the job. Now, what I'm going to do is hook them in series. So I'm going in on the brown wire here, if I can get hold of that, and then I'm going to hook up the other lead on the other light on a capacitor here. And what's going to happen is it's a sum of the reciprocals. It's in your handout. In other words, if you put 1 over 30 and 1 over 10 and do the math on fractions and whatnot, it'll come out with a number. But what it always is, I've got a 30 and I have a 10, and when I have them in series, the total capacitance is going to be less than the smallest capacitor. So I'm going to turn this rascal on, and I have, I don't know if you can see it, 7.9. But 7.9 is less than 10, so I've got them in series. It's not something you would normally do. I'm pointing it out so if you're in that situation that say, well, boy, I can put a 20 and a 30 together and get 50 microfarads to get the customer running, but I don't remember which way to hook it up. Well, hook them up one way or the other with your meter, and you're going to do it. But if they're parallel, it's the sum of the two. And if I have two of them hooked up in series, the total microfarads is going to be less than the smaller of the two. So that's pretty much in it. We learned on another video how to replace a dual capacitor with two singles. Capacitors are one of the most common failures as far as air conditioning is concerned. And one of the hardest things to do is when you use one, what I do when I use one on the job, I put that empty box on my console somewhere where I see it, so the next time I go to the supply house, I replace it. Because if your luck is like mine, the next time you go to another job, you're going to need the same capacitor. So you want to make sure that you replace the ones that you use. That's it. If you have a question, send me an email, and I will put the question out for the whole class, and also the the answer. Okay, that's it for it. Take it easy.